Now that we've covered fields, properties, and indexers, it's time to introduce the fourth member type, which is methods. In programming, methods are like building blocks that help us organize and structure our code. For example, the main method is the starting point for every C# application. When we run the program, the main method is called by the common language runtime. Okay, methods, including the main method, consist of statements that work together to build our program. In this lecture, we'll discuss what methods are and when to use them. We'll also explain the basic parts of a method and how to create one. Hello guys, welcome again. Alright, let's start with the basics. What is a method? In simple terms, a method is like a block of code that does a specific job. In C# programming, a method is a block of code that contains a series of instructions. When we call a method, we make those instructions run. You can think of a method as a set of instructions that tell the computer how to do a particular task. Okay, when we want to represent the attributes or characteristics of an object, we use fields and properties. For these members, we give them names that are nouns or noun phrases. For example, in a person object, we can have fields or properties like age or date of birth. On the other hand, methods are used to perform actions or behaviors of an object. We name methods using verbs or verb phrases. For instance, if we have a method called calculate age in a person object, it means it calculates the age of that person. Alright, a method can be defined within a class, so let's create a class named calculator. Inside this class, we make a method that calculates the sum of two numbers. The structure of a method has several parts. First, we have access modifiers like public and private, which determine who can see and use the method in the program. Methods, like other class members, can have one of 6 access modifiers. If we don't specify one, the default is private. In this case, let's make our method public. Next, we have the return type, which tells us what kind of data the method will give back after each execution. The return type can be a predefined type like int or string, or it can be a custom type like a person class. If the method doesn't give back any data, we use the keyword void. In this case, we use int as a return type. Okay, after the return type, we have the method name. The method name is a special name that helps us refer to the method when we wanna use it in our code. It's important for the method name to make sense and describe what the method does. As we mentioned before, the method name should be verbs or verb phrases that represent the action or purpose of the method. In this case, let's name our method sum to indicate that it performs an addition operation. After the method name, we have parentheses. Inside these parentheses, we can have parameters, which are like placeholders for data that we can give to the method. Parameters are defined within the parentheses and separated by commas. Each parameter has a type and a name, which helps the method receive and work with specific values while it runs. In our method, we have two parameters, number 1 and number 2, and both are of type int. So let's say int number 1, comma, int number 2. By utilizing these parameters, our method becomes more flexible and reusable. On the other hand, without parameters, we would need to create a new method for each pair of numbers we want to add together. But now, thanks to the parameters, we can use the same method to add different numbers together. Alright, moving on, we have the method body, which is enclosed in curly braces. The method body contains a series of statements that define what the method does. These statements can include things like creating variables, doing calculations, making decisions, and repeating actions. The method body is where the actual logic and functionality of the method are written. It's important to remember that it's best practice to have each method focus on a specific task. This principle is called the single responsibility principle in programming. Following this principle, it's recommended to assign each method a specific job or task. Okay, at the end of the method body, we need to give back a value that matches the type we have specified for the return type, unless it's void. If we forget to return a value or return the wrong type, we'll get an error. In our case, since we haven't returned an int value, we're facing an error. To get rid of this error, we can use the return keyword to give back the sum of the two parameters. Alright, now let's talk about how we can use or call methods in C#. First, we need to create an instance of the calculator class because the sum method is an instance method. To call this method, we use the instance name followed by a dot, then the method name, and finally we put parentheses and a semicolon. Inside these parentheses, we can provide some arguments. Arguments are the actual values that we pass to the method's parameters. The arguments must match the parameter types and order that are defined in the method. For example, the sum method has two parameters of type int, so we need to pass two int parameters when we call this method. Finally, if we want to keep the value that the method returns, we can declare a local variable with the same type as the method's return type. Okay, just like properties and indexers, methods can also be written as expression-bodied methods. In the case of the sum method, since it has only one statement, we can make it an expression-bodied method to keep it concise. Alright, let's understand what happens when we call a method. When a method is called, the program jumps to the method's body and runs the statements inside it. Once the method finishes its execution, it goes back to where it was called and continues executing the remaining statements. This feature makes it easy to reuse code because we can call the same method multiple times from different parts of our program. Okay, done. See you soon.